most awesome thing about teaching physics is I get to play with toys. I'm Steve Groven, and today's topic is momentum. And if you recall, momentum is the law of momentum, which is Newton's third law, action and reaction pairs. Okay, so let's start talking about momentum. First off, I'm going to show you a little video clip of my Newton balls. Again, playing with toys. Now, if you notice, if you've ever played with Newton balls before, you'll notice that when you pull the Newton balls out, when you pull one out, let it go, the three balls in the center, okay, I'm now doing two in this video. So in the first part, one ball was exactly transferring its energy to the ball on the end. Two balls transferred 2 balls worth of energy. So what is 3 balls going to do? Going to transfer exactly 3 balls of energy to the other side. Now in this case, the entire momentum of the system is being transferred. Okay, so 4 balls and 4 balls of energy are being transferred. Another trick I like to do, pull 1 ball out each. Now what if I pulled 3 and 2? What's going to happen? Again, a total transfer of energy. 3 balls are transferring 3 balls of energy worth to the other side. So if I do 4 balls, and I should get exactly the same thing. Okay, I'm sick of this. Let's try something else. Okay, so the actual definition of momentum is it's the product of the object's mass and its velocity. So since we're talking about a law, we are talking about a mathematical equation. Mass measured in kilograms and velocity measured in meters per second. Now the shorthand version of this particular law is P is equal to mv, and let's take a look at how the math works. Okay, the topic right now is momentum. Okay, now the definition of momentum is mass multiplied by velocity. Okay, in other words, the definition of momentum is just a mathematical equation, and we write that mathematical equation like P is equal to mv, P standing for momentum, m standing for mass, and v standing for velocity. Remembering velocity is a vector quantity, so it's going to be in a particular direction. Honestly, I have no idea why we use a P. I asked another science teacher about that once. He'd been teaching a lot longer than I had been. He did not know either. Okay, so let's try a couple problems. First off, looking at this particular problem, the bucking bronco is going to throw an 81 kilogram rider, remember, mass is measured in kilograms, into the air at a velocity of 10 meters per second upward. Again, velocity, vector quantity, has to have a direction. Okay, so momentum, momentum is going to be your P is equal to mv, so we just need to take the mass of the rider, 81 kilograms, multiply that by 10 meters per second. Remember, you're going up. Get out your calculators if you need them. Personally, I don't think you need them on this one. And you should find the answer is 810 kilogram. Oh, sorry about that. 810, and this is where the units come in. Kilogram meters per second up. Momentum, for some reason, doesn't have any specific units. They just simply use kilogram multiplied by meters per second. Okay, so let's go on to the second problem. It's a little bit more challenging this time because, well, if you notice, we've got a boat, mass of 1,500 kilograms. We've got 2 passengers. Their mass is 180 kilograms. And we have the velocity, 15 meters per second west. Now, if you think about it, all we need to do in this problem is add the masses together. So we got the mass, or whoops, sorry about that. So the total mass is going to equal to 1,500 kilograms added to 180 kilograms. And you're going to get a total mass sorry about that, total mass of 1680 kilograms. Okay, now that we have the mass, now we can figure out the momentum. In other words, P is equal to your mass. I won't rewrite the formula. We should just know that by now. So 1680 kilograms, 1680 kilograms multiplied by 15 meters per second west. Okay, sorry about that. Stick the west in there. Okay, so get out your calculators, multiply it together, and you're going to get 25,200. And I kind of ran out of room, so I'm going to stick my units right down here. Paper and pencil is usually a lot easier to deal with. So that'll be kilogram meters per second. Okay, again, I'm apologizing for, oh, sorry, that should be west. I'll stick that west in there again. Okay, again, I apologize for the handwriting. Not exactly at my best with handwriting. Okay, this one's going to present a bit more of a problem. If you notice the question, we're not asking for the momentum this time. We are asking for velocity. Okay, so let's do a little algebra here. Add the equation P is equal to mv, and since we want our velocity, we need to get velocity by itself. Okay, now those of you who have been in algebra or are in an algebra class know that because we're multiplying mass times velocity. Did I say volume? Mass times velocity. You know that we're going to have to do a division in order to get the velocity by itself. All you need to do is divide both sides of the equation. Remember, what you do to one side, you do to the other. Divide both sides by the mass, and we're going to learn that P over M, sorry about that, is equal to V, or your velocity is equal to momentum divided by mass. Okay? So let's bring that over here. We know that velocity is equal to momentum divided by mass, so that's 440 meters per second, and we're going forward, divided by the mass of the skater, 55 kilograms. And those of you who understand unit or dimensional analysis will notice that our kilograms are going to cross out, leaving us with the unit of meters per second. So velocity is equal to 440 meters per second divided by 55. When you do that, you're going to find that the velocity of our skater is 8 meters per second forward. And that's momentum math. Okay, so let's move on a little bit. Let's talk about the law of conservation of momentum. Now, this is what happens when two objects actually collide. I'm say it again. Anytime objects collide, the total amount of momentum stays the same. Now, if you notice, this is a law, therefore there will be a mathematical equation, and there it is. P1 is equal to P2, or M1V1 is equal to M2V2. Simply stated, the momentum of the first system is exactly equal to the momentum of the second system. Okay, so this is a little experiment that I tried earlier when basically I was just knocking blocks together. Now, if you notice, I wrote all of the masses of the blocks onto the blocks, so you can kind of see what's going to go on. Okay, so let's take first the small block and a larger block. All I'm going to do is knock it together, and of course the smaller block is going to move the larger block a little ways, but watch what the larger block does. That one just kind of knocks the smaller block off the screen. Okay, two more blocks, large and small. Again, the small will move the large a little ways, but the larger is just going to knock that one out. Okay, I'm using the same force every time I knock the blocks together. Okay, so let's go a little ridiculous. Really small with a large. Okay, not very good. Try that again. Little better, but I had to use a lot more force. Okay, so let's try that again with the small, and I'm actually not using a lot of force. And of course, the small block is just gone. Let's go large and large. Okay, let's go large and not so large. Not a lot of distance. Okay, Again, I'm using the exact same force, and there we go. Now let's try the large and large, see what happens. Okay, so you guys already have a very good idea of what's going to happen every time I'm doing this. I'm just kind of knocking blocks around. Okay, and there we go. That was my little experiment. Okay, so that kind of answers the first what if question I want to put up here. So if we have two objects collide together, they bounce off each other. Now, if you notice from the video, what's happening is the total momentum, or the momentum of the first block, is transferred to the other. And every time this happens, the transfer will cause the objects to move in different directions from each other, unless the first block is still going. Well, if you did notice, each time I knocked the second block, the first block actually slowed down a little bit. Energy from the first block was completely transferred to the other block. Okay, so what's another possibility? What if the two objects stick to each other? Now that's a collision. Whoops. Okay, I guess they're not sticking to each other in the case, but you can kind of see what's going on in this collision between a Chevrolet Bel Air and a Chevy Malibu, the old versus the new. And these kind of collisions are exactly why physics is so important. What people in physics are trying to do in this case, they're trying to help you survive. What if you get into a collision? You are going to be a hurting unit. Okay, so if the two objects actually stick to each other, then they're going to move as one object. The masses will combine into one, and the objects will have a different velocity due to the increase in mass. If you recall, the law of momentum states that for every action, there is an equal and opposite reaction. This is because, if you recall, all forces are going to act in pairs, and those pairs are action and reaction pairs. You exert a force, there is always going to be a reaction force. And what the reaction force is doing is transfer momentum. Okay, well, thank you very much for listening.